I'd like to take a moment and review the control and overtemp TCs. We normally stick with the type S thermocouples, and they're Inconel sheath on the outside and ceramic sheath in the inside, which I'll show you in a minute. And then you can see the gland at the bottom, compression fitting, which allows for adjustment, which we'll discuss, the insertion depth of the TC. Now let's move to the inside of the furnace where we can talk a little more quietly. I'm going to use a type K thermocouple for my pointer and for further reference. So we have our control TC and our overtemp TC, and you notice that they're made out of ceramic. They are not the old-fashioned all-metal TCs, because the old metal TCs don't have the response time for the lower temperatures, and it's much harder to control the furnace and keep uniformity within specification without overshoot for the aerospace and nuclear arena. So our standard is then transposed over in the years to the ceramic sheath, because everybody knows that the open tip TC is forbidden in 2750. So we have our two TCs here, and when we go to change a TC, basically on the outside that we looked at, it's just a compression knurl fitting that's on the TC that we loosen up, and then the TC just pulls right out of the fitting, out of the furnace, and the TC is out. The TC goes back in, the compression fit is tight, and then the TC is back in place. Now, you're thinking, okay, who doesn't know how to change a TC? Anybody can do that. Now let's look at the question that comes along with changing our control TC. Most of us are familiar with this little piece of paper here called 2750. And in 2750, there's a lot of valuable information. And unfortunately, my own personal opinion this is, there's a lot of areas where it's not open for interpretation, I want to say, but understanding. One of the common things I've heard in my 37 years of traveling from inspectors and customers, some are under the impression, excuse me, if I break a control TC and I replace the control TC, that means a mandatory recertification of the TUS of the furnace, Temperature Uniformity Survey. And I know a lot of customers where the operator takes and accidentally breaks the control TC, and immediately they think that they have to recertify the machine and waste 24 hours of production's worth of time. I've seen that many, many times. The inverse to that is I've seen customers and inspectors that say, no, you don't have to recertify the machine, as long as after the survey you have recorded the as discovered and as found thermocouple immersion depth into the furnace. A general rule of thumb for most furnace applications is the tip of the control TC is normally 2 to 3 inches past the surface of a heating element. That's a good starting point. And then from there, you do your temperature survey, you balance the heat load across the hot zone, and when you're all done trimming the survey as tight as you possibly can get it, then you go back to your set point. And if my set point number 1 is 1,000 degrees Fahrenheit, and I have a spread throughout the hot zone load of plus or minus 5 degrees, but it's deviant from the control set point temperature, then I adjust the control TC, and I either have to push it further into the hot zone or pull it further out to bring the load up or down to match the tip of the thermocouple. So if a thermocouple is damaged, broken, and needs to be replaced, the thermocouples have tags on them, which is attached to the certification sheet. If the thermocouple is from the same family or extremely close within the specification of 1.2 degrees, roughly, then as long as your book is recorded the as discovered and as found thermocouple immersion depths, if I break a TC, I can prove to the auditor that I'm replacing it with a like TC with equal to or exactly the same calibration curve, and I've recorded where it was, so when I put my new TC in for my insertion depth, I'm guaranteeing it's exactly where it belongs and where it came from. In that case, most inspectors now are saying you do not have to recertify the equipment because you've recorded as found, as discovered, as tested, as left information. So there is not the need to recertify the furnace upon controlled thermocouple replacement. You will hear both sides argued. You will hear both customers on both sides. You will hear inspectors on both sides. But I'm finding it more and more and more common in the industry. If you're recording the TC immersion depths and can prove it, and it's from a like family calibration curve, there's no need to recertify the machine and invest an additional 24 hours of your time. Not trying to start any controversy or naysaying, but when you read things and it says 3.53 furnace modifications, and they give some examples of furnace modifications that may require recertification of the TUS and SAT. One is a change of control sensor location. So again, if you cannot prove where the thermocouple was prior to it being broken, and you put a new thermocouple in, even if they're from the same roll of wire with the same exact certification, you're changing the placement because you cannot prove where the thermocouple was prior to the incident. So as long as you're recording on your SATs or TUSs where it was and where it is when you're done with the survey, then you meet number H, change of sensor location, because you're not changing it and you can prove you didn't change it. And or under 4, K4, adjustment or tuning constants, parameters, and rheostats. We're really not messing with any of those. We're just replacing the control TC. And like I said, all we have to do is say, I can prove where it was, I can prove I'm putting it back in the same position, and I can prove that the certifications are the same. End of story in most people's opinions.